NASA's space probe, Explorer-1, has delivered a stunning warning to Earth. This remarkable spacecraft, initially designed with a 5-year lifespan, has far exceeded expectations, continuing its mission for nearly 5 decades. It has become a trusted tool for scientists around the world, making groundbreaking contributions to our understanding of space. Recently, Explorer-1 made an extraordinary discovery, detecting 300 unidentified objects passing through space. Join us as we explore this shocking revelation and dive into the mystery of these mysterious flying objects. While we marvel at the beauty of Earth's natural wonders, the flowing waterfalls, towering mountains, and vibrant ecosystems, it's important to remember that our planet is just a glimpse of the grander cosmos that stretches out beyond us. For centuries, scientists have pondered the mysteries beyond our solar system, and the search for answers has led to the development of bold missions like Voyager 1. This spacecraft, mankind's most ambitious venture into space, has ventured far beyond the reach of our most powerful telescopes, gathering invaluable data about interstellar space and sending it back to Earth. Explorer-1, after completing its incredible journey, has sent a surprising message that has left scientists in awe. NASA's trusted interstellar spacecraft recently announced the detection of 3,000 mysterious objects passing by in space. Before we delve into the unknown nature of these unidentified objects, let's take a moment to look back on one of humanity's greatest achievements in space exploration. In August 2012, Explorer-1 reached the outermost boundary of our solar system, crossing the heliopause. This was no easy feat as the spacecraft ventured farther from the Sun. The availability of sunlight to power its instruments dwindled. The spacecraft relied on 3 radioisotope thermoelectric generators, RTGs, to convert heat from the decay of plutonium-238 into power. Over time, the decreasing heat output from these RTGs has resulted in reduced available power, directly affecting the operation of various onboard systems, including scientific instruments, data transmission, and communication capabilities. To conserve energy, certain non-essential systems have been deactivated or placed in sleep mode. However, as power continues to decline, critical systems may need to be further optimized or even shut down to extend Explorer-1's operational lifespan. The reality is that if no measures are taken, Explorer-1's ability to function will be severely limited, and even if it manages to continue operating, its usefulness could be significantly reduced. Compounding these challenges is the immense distance between Explorer-1 and Earth. As it journeyed into interstellar space, the strength of its signal diminished considerably. It now takes over 21 hours for a signal to travel from Explorer-1 to Earth. This weak signal, combined with interference from background noise, presents a major obstacle to effective data transmission. Additionally, Explorer-1 now faces extreme temperature fluctuations as it crosses from the heliosphere into interstellar space. Within the heliosphere, the spacecraft was closer to the Sun, experiencing higher temperatures. But as it ventured into interstellar space, it encountered extremely cold temperatures. These drastic temperature changes can affect the spacecraft's materials, electronics, and systems. The expansion and contraction cycles caused by these temperature variations could compromise the structural integrity of certain components. Extreme cold can also make materials brittle, leading to potential cracks or degradation of seals and connectors. These temperature fluctuations also impact the performance of the RTGs, which are designed to operate within specific temperature ranges. The cooling of the RTGs exacerbates the power difficulties already faced by the spacecraft. In addition to these power and temperature challenges, Explorer-1 encounters tiny particles of dust in interstellar space. Although these particles are incredibly small, they pose a threat to the spacecraft. When the spacecraft encounters interstellar dust, these particles can collide with its exterior, causing wear and tear on protective coatings, antenna surfaces, and other sensitive areas. The accumulation of dust on the spacecraft's optics or sensors could hinder their ability to collect data, degrading the quality of the information returned to Earth. Furthermore, NASA's global network of deep space communication antennas must allocate limited resources to receive signals from Explorer-1. This allocation of resources means that communication opportunities with the spacecraft have become more sporadic than ever. The continued decline in signal strength further complicates the retrieval of data and transmission of commands. But before we get lost in these challenges, let's take a moment to appreciate the incredible accomplishments of the Explorer spacecraft. The achievements of the twin Explorer probes stand as a testament to human ingenuity and the unyielding spirit of exploration. Over 40 years ago, the Explorer spacecraft embarked on a journey that forever changed our understanding of distant worlds in our solar system. Their initial observations of Jupiter and Saturn's moons shattered expectations, revealing dynamic and active worlds instead of the barren, scarred landscapes once imagined. Explorer 2, in particular, is known for its extraordinary achievements. In 1986, it became the first spacecraft to pass by Uranus, providing humanity with its first close-up view of this enigmatic planet and its moons. Just 3 years later, Explorer 2 made another significant contribution by flying past Neptune, uncovering the wonders of this icy giant. To this day, Explorer 2 remains the only spacecraft to have ventured into the realms of Uranus and Neptune, a testament to its pioneering spirit. As the Voyager missions continue their epic odyssey, NASA has implemented various measures to extend their operational lifespan. Non-essential parts and heaters have been deactivated to conserve energy, and engineers have worked tirelessly to ensure these brave explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030, a remarkable achievement that highlights the resilience and durability of the Voyager spacecraft. For the dedicated scientists and engineers involved in this exceptional endeavor from the very beginning, the culmination of the Voyager missions is both a moment of pride and a bittersweet farewell. Their unwavering commitment and passion have far surpassed initial expectations. The wealth of data returned by the spacecraft has provided invaluable insights, fueling numerous scientific discoveries and sparking the imaginations of countless space enthusiasts and scientists. What truly sets the Voyager spacecraft apart is their meticulous design. With a rotation rate 15 times slower than the hour hand of a clock, the spacecraft were built to minimize visual blurring while capturing images and data as they traveled through the vastness of space. Even in the harshest conditions, these spacecraft have become iconic symbols of human determination and the unrelenting quest to explore the cosmos. The experiences of space missions with distant planets, particularly through impressive imaging capabilities, have left researchers and the public astounded. Months before reaching Jupiter, the Explorer spacecraft began transmitting images of this gas giant, captivating audiences at NASA's Jet Propulsion Laboratory. These early images showcased Jupiter's mesmerizing swirling clouds and the iconic Great Red Spot, leaving viewers in awe. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly captured the world's attention. Slightly larger than Earth's moon, Io became the most geologically active body in our solar system. The spacecraft's instruments detected distinctive signs from Io, which were confirmed by striking images of volcanic plumes and a surface scarred by volcanic activity. One of Io's most prominent volcanoes erupted with a force 30 times greater than Mount Everest, covering an area nearly the size of France. Although the Explorer spacecraft's cameras were eventually powered down to conserve energy and memory before venturing into deep space, it's important to note that the images they captured did not include Mercury and Mars, due to various limitations. Beyond Explorer 1 and 2, NASA also worked with other notable space probes, such as Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed by Pioneer 11, marking the moment when Pioneer 10 became the most distant spacecraft. Explorer 1 continued its solitary mission for 14 more years before entering interstellar space on August 25, 2012. Although no other spacecraft was in sight, NASA didn't officially announce this remarkable milestone until 2013, adding to the intrigue surrounding the Explorer missions. A key strategy that played a vital role in the success of the Explorer missions was gravity assist maneuvers. These maneuvers were crucial for propelling Explorer 1 and 2 on their daring journeys to explore the outer reaches of our solar system. Instead of relying solely on their own propulsion systems, the spacecraft used the gravitational pull of massive planets to slingshot themselves through space. This allowed them to conserve fuel and gain the necessary speed to visit multiple destinations, leaving behind a legacy of exploration and discovery. One of the most significant revelations from the Explorer missions was the detection of 300 unknown objects, which sparked great interest and speculation among scientists. As Explorer 1 faithfully gathered and transmitted valuable data back to Earth, researchers were faced with perplexing signals. The data appeared garbled and unclear, raising many questions. Despite this, Explorer 1 remained fully operational, continuing to send critical information to NASA without triggering any of its safety protocols. This led researchers to wonder what could be causing the scrambled telemetry data. Was it interference from cosmic radiation or high-energy particles, or could it be something entirely unknown lurking in interstellar space? If it was the latter, it would challenge our current understanding of space and communication in the interstellar medium. In the search for answers, NASA's team meticulously examined various factors that could explain the anomalies, including the potential impact of cosmic radiation on the spacecraft's electronic systems and the possibility of temperature fluctuations affecting its delicate instruments. It was also considered that something unusual might have occurred just before Explorer 1 reached the heliosphere, causing disruptions in the data transmission process. However, it became evident that Explorer 1 was not in a region where such difficulties should have posed a significant risk. The team also explored the possibility that signal distortion could be caused by noise interference or subtle changes in the spacecraft's orientation. The investigation process was thorough, requiring several weeks of analysis. By utilizing advanced data processing techniques, new algorithms and simulations, the team was able to isolate the root cause of the telemetry issues. After weeks of receiving confusing data, researchers and engineers successfully restored clarity and reliability to the information being transmitted from the far reaches of interstellar space. It was discovered that the issue stemmed from Explorer 1's attitude control system (ACS), specifically from a dormant onboard computer. This malfunctioning computer had unexpectedly powered on, causing the degradation of the transmitted data. However, the rest of the spacecraft systems remained fully functional, and data collection continued without issue. Once the source of the problem was identified, engineers quickly devised a solution. They sent a command to Explorer 1 to switch to a backup computer for transmitting telemetry data, a process complicated by the 22-hour radio transmission delay between Earth and the spacecraft. Using 1970s-era manuals, they successfully reset the system responsible for data transmission, resolving the issue without compromising the spacecraft's other functions. This restoration demonstrated the importance of combining historical knowledge with modern technology to overcome challenges in space exploration. Researchers suspect that a faulty command triggered Explorer 1's switch to the non-functional computer. Despite this setback, mission operators remain optimistic, emphasizing that the incident did not affect Explorer 1's long-term success. The spacecraft's journey beyond the heliosphere marked its entry into interstellar space, where subsequent observations, including changes in particle intensity and magnetic field strength, expanded our understanding of the heliosphere's boundaries and interstellar phenomena. Explorer 1's mission also raised questions about the mysterious objects it detected, sparking theories about rogue planets, ancient interstellar probes, and possible extraterrestrial involvement. These discoveries continue to inspire scientific investigation into the true nature of these unidentified objects and Explorer 1's remarkable encounters.